Welcome to my YouTube channel, Amateur Francis. But before we proceed further, like I said earlier, you have to subscribe and like in order for you to be able to get the subsequent videos. In our previous videos, we talked about the various formulas which we can use in order to resolve all calculations associated with volumetric analysis. So now we are about to start the calculations themselves today. And the first one we're going to deal with is standardization. So I have a whole lot of them. For example, I have standardization of solution, determination of relative molar mass, determination of mole ratio, determination of the degree of purity of a substance, and determination of water of crystallization. So today we are going to be dealing with the various calculations that are associated with what? Standardization of a solution. Permit me to read the question, but I'm not writing it. But then there is a pattern in which we're going to deal with it, because after the question has been read, the best way to resolve a problem is to start with given. You have to list out the various variables in a form so that when you're dealing with it, you know what you're dealing with. So the question is, A is a solution of tetraoxosulfate 6 acid. A means acid. Anytime we talk about A, you should know that we're dealing with acid, we're talking of acid. B for base is a solution containing 0.050 mole of anhydrous sodium triacylcarbonate 4 per dm cube, and titrate 20 or 25 cm cube portion of B using methyl orange as the indicator. Record the size of your pipette, tabulate the burette readings, and calculate the average volume of acid used. From your result and the data provided, calculate the amount of sodium triacylcarbonate 4 in 25 cm cube of B used. Alright, let me now start telling you right now. 2. Concentration of A in mole per dm cube. 3. Number of hydrogen ions in 1 dm cube of A. 4. Mass of sodium ion formed in solution during the titration. Avogadro number is given to be 6.02 times 10 raised to the power 23 mole. And since this is a titration question, it is believed that we've done the titration and the volume of acid is 24.38. But then let us start by writing out the given. A is H2SO4, B is anhydrous sodium triacylcarbonate 4, now they give us Ca, Cb, concentration of the base is given to be 0.050 mole per dm cube. Ca, would I know? Yes. Put solution A and titrate 20 or 25 cm portion. So let's take 25 portion of B. So the volume of the base is 25 cm cube. And after the titration, we now have the volume of the acid. The average volume of acid was gotten to be 24.38 cm cube. From your result and the data provided, calculate the amount of sodium triacylcarbonate 4 in 25 cm cube of B used. Now, remember, I gave you a whole lot of formulas for amount. One of the major formulas for amount is molar con times volume. But remember, I said the volume must be in dm cube, which means we divide it by 1000. So let's start. Now, question number 1, amount. of B is equals to molar count of B times volume of B. Now, what is the molar count of B? Obviously, this is our B section and this is our A section. Our B, we have the concentration of the base to be this. So, this is equals to 0.050 mole per dm cube times the volume. Get me the calculator. The volume of the base is 25. So this is 25. Remember, we said we converted, the unit is in dm cube. So we convert it to what? Dm cube by dividing by 1000. So this is over 1000, which is in dm cube. This is equals to, it is advisable that when you're dealing with the calculations, you make sure you don't make mistakes. One mistake can send you to the wrong side. So we have 0.050 mole per dm cube times 0.025 dm cube. No minus yet. When you multiply these two times 0.05, our amount is 0. That's the first section and the first question. They say that we should calculate amount. You remember the formulas for amount? I gave you mass all over, relative molecular mass, and also molar count times volume. So provided you can remember the formulas, then you can solve the question. If you forget the formula, you miss the solution properly. So that is it. We are done with amount. Let's look at the next question. Concentration of A in mole per dm cube. Now, remember I gave you about 3 formulas for concentration. The first one being our CAVA, CBV equals to NA all over NB. We also have molar count, which is equals to mass count divided by relative molecular mass. We also have the other one, which is, okay, the other one is not important in this essence. So in these 2 formulas that I've just mentioned, the one that is more expedient for us to use is our CAVA, because the concentration of the base has already been given, the volume of the acid is known, the volume of the base is known, the number of moles of acid and the number of moles of base can be known only if we balance our equation of reaction. So I'll be able to get our Na and our Nb. So by so doing, I'll be able to add them here. So remember, we're dealing with let me check. The acid is H2SO4 with the sodium triacylcarbonate 4. So the equation of reaction, so that I'll be able to get my Na. Let me write it here. My Na and my Nb. From the equation of reaction now, I have H2SO4 plus Na2CO3. So this will give me sodium sulfate plus water plus CO2. We have 2 hydrogen, hydrogen is balanced. SO4, we have SO4, 2 moles of sodium. 2 molecules of sodium. Here, we have to put 2 here. Carbon is 1. Oxygen is 3 plus 4, that's 7. So I have 4 here plus 1, 5 plus 2, 7. The state of the equation, this is aqueous. Aqueous, liquid or solution, and this is gas. Or I just put your gas, as the case may be. So the state of the equation must be known. So having balanced the equation, now we know the number of moles of the acid and that of the base. the number of moles, there's nothing before this, which means the number of moles of the acid is 1 in this essence. So I can put my Na to be 1, my Nd to be 1. So now you realize if I'm using my CAVE, I've gotten almost every parameter I need. So I can easily substitute into the equation of reaction and proceed. Permit me if I have to clean this other section. Okay. Alright, the question number 2, which is concentration of A in mole per dNq. I'll now write my formula, since I know the right formula to use, which is CAVA over CBVB equals to NAND. But I'm looking for concentration of the acid, which is not known. That is what I'm looking for. So what do? I make my CA the subject of formula. Just on it, behind and in front. I make my CA the subject of formula. So let's see what happens. Now, for the sake of those who do not understand, change your formula very well. So we are going to practicalize it and see how that works, alright? So now here we have this multiplied by this, we have CAVAND is equals to CBVBNA. I'm looking for CA, so I will divide both sides by VAND. So VAND. This will cancel itself, and I have my CA is equals to CBVBNA all over VAND. This is equals to, now what is the concentration of the base? It was given to be 0.050 mole per dNq times, what is the volume of the base? VB is 25 cm3 times, what is the number of moles of the acid? We have it 1 from the equation of reaction. This is 1, this is 1, all of them 1, 1. This is all over, what is the volume of the acid, which is 24.38. 24.38 cm3 times, what is the number of moles of the base, which is 1. So this is equals to 0.0513 mole per dNq. Now, the variables here are mole. We have 0.05127153. But remember, in chemistry calculations, all our answers are always kept in 3 significant figures. So take note of that. So this is our answer. So we've been able to solve the second question they asked. Now let's look at the third question here. Number of hydrogen ions in 1 DN cube of A. Now, permit me again, I have to clean the board. I'll come back here. Okay, number of hydrogen ions. Now we'll go back. H2SO4 will dissociate or ionize to give us 2 hydrogen plus SO4 2 minus. That's what you get. So because they are now referring to ion, you can only get ions when H2SO4 must have undergone dissociation or ionization to give you its ions. So this is what the ionized equation of H2SO4, which is this. Now remember, this is where we are looking at the hydrogen what? Ion. So now they say number of hydrogen ions in 1 dm cube of A. So from A, what do we have? The mole per GM cube of A here was calculated to be this. So we'll come back here and say 1 mole of this, officially first, 1 mole of this give us 2 moles of this. This is mole concept. I will in due time have classes under mole concept so that you'll be able to understand better the volumetric analysis calculation, because it's difficult for you to excel in volumetric analysis calculation without a vivid knowledge of mole concept. So we apply mole concept almost in everything we do. So for the now, you have to permit me, as time goes on, I will introduce the mole concept so that you will begin to understand what we do better. So right now, if 1 mole of H2SO4 gives us 2 moles of hydrogen ion, then 0.0513 moles will give us X. If I cross multiply as usual, I will have my X which equals to 0.0513 times 2, which is equals to 0.0513 times 2. We are having 0.1026 mole of hydrogen ion. That's not all. We're still going to proceed. I choose not to approximate to 3 significant figures because I'm still going to make use of the variable. So let's proceed. Now, 1 mole of hydrogen ion is equivalent to 6.02 times 10 raised to the power 23 ions. 0.1026 moles will be equivalent to X. Remember, we're looking for the number of hydrogen ions. So which means we're still doing this almost the same thing. We're still going to cross multiply. And cross multiplying again means this times this is our answer, because this already is 1. So my X is equals to, proceed, 0.1026 times 6.02 times 10 raised to the power of 23. That gives me 6.17 or approximately 18 times 10 raised to the power 22 ions. So that's what we get for that. We've still not finished. Remember, we've done number of hydrogen ions in 1 dm cube of A. Now the fourth one is mass of sodium ion formed in solution during the titration. I will have to clean a little bit again. Remember, we have been able to calculate the amount of the sodium triazocarbonate form. Sarah, come so that you give us the value for the amount for sodium ion. So the question again says mass of sodium ion. They are looking for the mass. The other one was the amount, which is mole. So first of all, we have to write our sodium to CO3. This will give us 2 sodium plus CO3 minus. Now, we are looking for the mass, but first of all, let me get my amount of this guy. So from there, I can proceed. I think there are various ways which you can do that if I want to. But then we have this. Please.
0.0125.
Okay, 0. That is the amount of this guy. Am I right?
Yes.
Okay, which is 0. So now it is a mole constant which we are still going to apply the same principle which we are dealing with. Yeah. So in this other side, I'll first of all say the amount here, 1 mole of this gives me 2 moles of this. Then 0. What?
0.0125.
125 mole will give me what? X. So if I cross multiply, I will have my X to be this times this, which is 0.0125 times 2. 0.025. 0.025 mole of sodium. Therefore, remember this is our sodium. We are looking for the mass now. So now we are moving from mole mass relationship. So I will say the relative molecular mass of sodium is 23 grams. So I will say 23 grams, obviously like 1 mole of this is equals to what? But since we are dealing with mass, mole relationship, so I start with 1 mole of this is equivalent to 23 grams of sodium. This is equivalent to this, they are the same thing. Therefore, 0.025 mole is equivalent to X. So whatever we get from the X is our mass. So I will proceed as usual to say my X is equivalent to or is equals to this times that 0. grams. So we are practically done with the first question. Remember, they say again that we should find a mass of sodium ion formed in solution during the titration. So when you're done calculating your amount, remember the good thing about this last question is we started with our amount. So we calculated our amount. So we have to take it into amount mass relationship. That makes it easier for us. So everything about mole concept is to compare the various relationships that are required. Like the question before that one, which is the number of hydrogen ions, we did something similar too, where we have to ionize because they were looking for the ions of hydrogen. We have to ionize what? The H2SO4 to get what we want. So that is that about the question. So we'll take another question. I think all of these which we are solving fall under what? Standardization. So after standardization, we are going to move down to maybe amount and so on, percentage purity and so on and so forth. Let's take the next question here.